James Webb Telescope insane new discovery of alien civilization. One of humanity's most significant advancement in space observation is the James Webb Space Telescope, since it will have many more capabilities than any other space telescope we have ever used. The scientific community is highly optimistic about it. JWST will play a significant role in performing studies into incredibly far-off space objects which we've never been able to discover. One of the JWST's targets for searching for extraterrestrial life had been Proxima b, and we believe it is now just a step away from reaching that goal because an unusual signal has been found there that may indicate that the planet is emitting artificial light. Yes, what you've heard is true. Scientists want to know if aliens are responsible for the lights emanating from Proxima b. If so, then how does it affect us? What does JWST see? Join us as we explore James Webb's game-changing Proxima b discovery. Without spending any time, let's begin the video. Like our Sun, Proxima Centauri is a planet in the Proxima b galaxy with its group of planets surrounding it. This exoplanet had captured the attention of researchers ever since it was discovered in 2016. Researchers have also discovered Proxima c, although Proxima d has not yet been verified, but it has drawn a lot of interest from scientists. Given that it orbits in the habitable zone of the star smack in the middle, the planet might have liquid water and even life. Due to its mass being similar to Earth's, Proxima b might be a rocky terrestrial planet like Earth and contain liquid water. Proxima b orbits a star that is noticeably dimmer and less massive than the Sun while being close to our solar system. Since the exoplanet is tidally locked and rotates synchronously with its star, it has two sides, a light side and a dark side, with one side always facing the star and the other always facing away. Additionally, it is unknown if Proxima b has an atmosphere. Water, carbon dioxide and rock might all be present and interact on the planet's surface if Proxima b has an atmosphere, which is necessary to form the biochemical process that defines life. The planet is close to its star and orbits it once every 11 days. The planet's surface might be between -90 and 30 degrees Celsius or -130 to 86 degrees Fahrenheit. In early 2020, astronomers looking for evidence of extraterrestrial life discovered something weird. The Proxima Centauri red dwarf star, located 4.2 light-years distance from the Sun, appears to be the source of an unexplained radio signal. At least two planets orbit this star, one of which may be temperate and rocky like Earth, heightening the intrigue. When the researchers discovered the unusual signal, which they named BLC-1, they were using Australia's Parkes Observatory to analyze Proxima Centauri as part of a breakthrough listen, a decade-long search for alien broadcasts from the nearest million stars. Observations done between April and May 2019 detected the radio waves. According to Sophia Sheik, a graduate student at Pennsylvania State University and a member of the breakthrough team leading the signal analysis, it's pretty expected that now and then you'll see something weird, but this is interesting because it's weird that we're having to think about the next steps. BLC-1 is the most compelling discovery Breakthrough has made so far in its hunt for alien intelligence, or SETI, even though Sheik and others strongly suspect that the signal is human in origin. The team is working on 2 articles describing the signal and an incomplete follow-up investigation. Before the study was ready for publication, the detection was leaked to The Guardian. Even a slight suggestion of extraterrestrial life excites people, even as researchers continue to study the signal and specialists warn that there is almost an ordinary earthly explanation. According to Andrew Simeon, the lead researcher behind Breakthrough Listen, there's a lot of talk about sensationalism in SETI. The same reasons the public is so enthusiastic about SETI are the same reasons we are so enthusiastic about it and devote our careers to it. They are aliens. It's fantastic. Since my father's Project Ozma search in 1960, scientists have been scouring the skies for radio signals that might have an artificial origin. These murmurs from extraterrestrials are believed to resemble the broadcast humans use to communicate, unlike the radio waves the cosmos naturally creates. These transmissions would only operate inside a relatively small band of radio frequencies. As a further indicator that the radio source is emanating from a far-off cosmic object, such as a planet orbiting a star, they would also exhibit a distinctive drift that would indicate the source is traveling either toward or away from Earth. What if alien life exists on Proxima b? If so, a continual stream of potent radiation from its host star makes it improbable that life could develop on the day side. We'll make an effort to explain things simply. A tenth of the distance Mercury travels when it's closest to the Sun, or 4.5 million miles, is covered by Proxima b as it orbits the Sun. According to radio astronomers, radio signals that have already been detected near Proxima b are likely just interference from nearby natural sources. Because the side of the exoplanet that is radiation-free is permanently dark, any civilization that inhabits it may need to use powerful mirrors or extremely bright LED-style lights to illuminate their cities. This can help us find them if we use the right tool. To search for evidence of LED lights on the planet Proxima b, the JWST has been suggested by a group headed by Harvard astronomer Avi Loeb. They believe that if artificial light is present, it will be visible with the James Webb Telescope's near-infrared instrument by looking for telltale signs of LED light waves in the light coming from the planet and its host star. The scientists could determine whether artificial lights may be seen on a planet's dark side by computing light curves from Proxima b and its home star. The two scenarios that these researchers examined were artificial illumination with a spectrum that was the same as the spectrum of widely used LEDs on Earth, and artificial illumination with a narrower spectrum that produced an amount of light that was equivalent to all artificial illumination on Earth. They discovered that the JWST could detect 5% of star power, represented by LED-style artificial lights. The discovery of an alien culture by the Webb Telescope is unsettling, but investigating it is even harder. As a result, despite all the incredible things scientists think Proxima b might be hiding, they have not been able to explore one of the most well-known exoplanets thoroughly. For instance, can life from other planets exist on the exoplanet? Yet they now have a tool at their disposal with the James Webb Space Telescope launch. JWST is not the first telescope that people have put into orbit. NASA has a long history of employing strong observatories that have been sent into orbit to study the universe. The Hubble, which has accurately and magnificently captured images of numerous regions of the universe over many years, had been one of the most well-known and powerful telescopes before the launch of JWST. If compared, the JWST is significantly more powerful and expensive than the Hubble. The JWST was the most costly telescope ever launched, costing over $10 billion. It contains the most foldable portions and is also the most complex. For the telescope to fit on the rocket that would put it into orbit, it had to be folded up. The JWST orbits farther away from Hubble. The former orbits the Earth at a distance of around 350 miles, while the latter spins around the Sun at a distance of about 1 million miles. This implies that NASA won't be able to deploy humans inside the JWST after launch to repair or rebuild it. The James Webb Telescope's larger primary mirror, which spans 6.5 meters in diameter, allows it to capture objects that are billions of light years away. This successfully takes us back in time. The JWST will enable us to take the very first pictures of the universe. The new telescope uses infrared technology to find heat-emitting objects hundreds of kilometers distant. NASA constructed a shield underneath the telescope to protect the observatory from the effects of heat from the Sun and Earth. The 5-layered shield is enormous and will cover the tennis court in its entirety. NASA has made a mosaic of the initial images the JWST took to help the telescope's 18 main mirror segments perfectly align before it achieves its full potential. Despite the image's graininess, it serves as a great starting point for the laborious process of upgrading JWST's mirrors to take ultra-sharp pictures of the distant universe. The same star, HD 84406, is visible as 18 distinct points of light throughout the image due to the use of different primary mirror segments. Gathering the light required to make the image mosaic took up to 25 hours. The 18 images of HD 84406 were created by combining more than 1,500 images obtained by Webb while he was pointed in various directions around the star. If James Webb can recognize the narrowband light emitted by LED lamps, we will be able to pinpoint the planet's atmosphere. Using devices on the observatory to measure the amount of energy that is moved around the planet, researchers will then be able to generate light curves to check if they match those of an LED light source or not. Loeb and Associates used the JWST exposure time calculator to establish that the spacecraft might detect artificial light. Astronomers can use this tool to estimate what can be observed over any given time before the observatory is launched. They could determine whether they could distinguish between different flux values and those with wavelengths that correspond to the artificial light levels that would be anticipated from a civilization that was constrained to live in permanent darkness. In this case, the lights illuminating the permanent night side should be reasonably assertive, increasing the likelihood that JWST will be able to detect them. In addition to typical LEDs that are 500 times more powerful than those now found on Earth, the JWST will be able to show that artificial illumination of a size comparable to that of our planet exists. Here's a catch. Even if we are never able to explain this signal, and even if we rule out every single known human and astrophysical source, this does not necessarily indicate the presence of extraterrestrial intelligence. You are not entitled to claim that a signal was produced by aliens just because you are unable to provide an adequate explanation. That's because, as intelligent beings, aliens can theoretically generate any kind of signal. Anything mysterious in the night sky could be explained by aliens, rendering it ineffective as a scientific hypothesis for explaining an unknown signal. To properly hunt for aliens, you must first predict the type of evidence you expect to find and then go looking for it.